Hello student, I am Rameshwar Shah from science classes. Today I am going to start the second lecture of machine. In second lectures I am going to discuss about the how we can reduce this friction of machine. Means method of reducing friction of friction of simple machine. Simple machine. There are various methods from which we can reduce the friction of simple machine. First, by using ball bearing. Second, by making sliding surface smooth. By making sliding surface smooth. By using lubricant. Lubricant. By rolling instead of sliding. These all are the method of reducing the frictions of the simple machine. It means, and this is method of increasing the efficiency of simple machine also, because you already know as the friction of the simple machine decreases, then increase the efficiency of machine. Okay. Another principle of simple machine. Then principle of simple machine means there is a rule of the simple machine, and that are, if there is no friction in machine, then output work is equal to input work. It states that if there is no friction in simple machine, the output work is equal to the input work. That is output work is equal to input work. We already know output work is equal to L into LD. Input work is equal to E into LD. That all are the equals if there is no friction in machine. Okay. Another, I am going to discuss about the type of simple machine. There are various type of the simple machine, and about which we have to know in this chapter. Then type of simple machine. Types of simple machine. Like as lever, pulley, inclined plane, wheel and axle. Like as lever, pulley, inclined plane, V line XL, V line XL, screw weights. These all are the simple machine about which we have to know in this chapter. Okay. Then first of all, I am going to talk about the lever. Lever means a rigid bar, a rigid bar which is, and it may be straight or bent also, a rigid bar which is capable of rotating at a fulcrum is called lever. A rigid bar which is capable of rotating at a fulcrum is known as lever. Okay. Like as this is a lever, and in lever, and it is fulcrum, and we apply force here, and so applied effort here, and distance from this is effort, and this is load, then this is load, then distance of the load from fulcrum is known as load distance, and distance of effort and from fulcrum is effort distance. And this part are consist of the lever, like as load distance, effort distance. And in this way, when there are different factors, there is a 4 factors in which any one we have to find, then we use the formula, that is E L into LD is equal to E into ED. Like as L into LD is equal to E into ED. By this formula we can find. Okay. Like as, and here we have to find the velocity ratio, and here then effort distance is equal to effort distance by load distance. Effort distance by, like as here MA, we already know MA is equal to L by E, and here is equal to ED by LD, and efficiency MA by VR into 100%, and this is the principle of simple machine. By using this formula, we can find the different factor and which are unknown in the levers. Okay. Another, there are 3 type of the lever, we already know, and in previous classes that all are discussed. Then first class lever, second class lever, and third class lever, and a few I am going to talk about that all. First, types of lever. First class lever. Then what is the first class lever? Then first class lever means, like as fulcrum is lies between load here, fulcrum, effort. It means fulcrum lies between load and effort. Then this fulcrum here, 3 conditions may be, like as in first class lever, LD is equal to ED, first conditions. Second conditions, ED greater than LD, and third condition, LD is greater than ED. These all 3 conditions may be. And if in first class lever ED is equal to LD is equal to ED, then in these conditions the first class only able to change the direction of effort. It means change in direction of effort. In these conditions, the lever act as a change the direction of change the direction of effort. But when in first class lever, when ED is greater than LD, means if effort distance become greater than load distance, then in these conditions the lever becomes effort multiplier. Effort multiplier. Multiplier. Another, in this condition, if LD is greater than ED, then in these conditions lever act as a speed multiplier. Speed multiplier. It means sometimes questions ask the first class lever is, and which type of the machine the first class lever is, then it may be a 3 type of the machine. That is change in direction of effort also, effort multiplier also, or speed multiplier also, but that are in the different conditions. If LD is equal to ED, then change in direction of effort. If ED is greater than LD, then effort multiplier. If LD is greater than ED, then speed multiplier. In this way, I am going to talk about the second class levers a few. Second class lever. Second class lever. Here in second class lever, load is always lies between fulcrum and effort. Here effort, fulcrum, load. And here are situations, that is LD, ED is always greater than LD in second class lever. And because here load is lies between the effort and fulcrum, so ED is always greater than LD. And in these conditions, the lever becomes effort multiplier. Effort multiplier. It means, and which type of the machine the lever, second class lever is? Effort multiplier only. And sometimes this type of the questions ask why the second class lever is effort multiplier. Then second class lever is effort multiplier because ED is always greater than LD in second class lever. Okay. Another, in third class lever, in third class lever, effort is lies between load and fulcrum. Load, effort lies between load and fulcrum. In this condition, LD is always greater than ED. And this is the conditions of speed multiplier. Speed multiplier. Sometimes this type of the questions ask which type of the machine the third class lever is. Then third class lever is a speed multiplier because LD is greater than ED. Okay, this was for today about the levers. Another day I will talk about the pulley and other type of the simple machines. Okay, student, this was